Hi everyone, how are you all of you? Yesterday we are discussing the showing topic is introduction of spherical mirrors and their properties and uses of the in daily life. Now today we are discussing about most important sign convention for reflection of spherical mirrors. It is used to solving the problems about spherical mirrors. Now let us start the topic. Sign convention for spherical mirrors. Here we have to show the picture and understand the topic. Students, to solve numerical problems in mirrors, login, we use sign conventions. We, we should measure all distance from the pole of the mirror. Rules of sign conventions. First one, pole P is a reference point. All distances are measured from the pole along the principal axis. Distances measured in the direction of incident light are positive, and distances measured opposite to the direction of incident light are negative. Heights measured above the principal axis are positive. Heights measured below the principal axis are negative. Here we have to show in the picture. A. Concave mirror. In concave mirror, uh, direction of incident light is positive. That indicates green arrow. And the distance measured in the direction of incident light are negative. That indicates red arrow. Okay, here negative distance. Okay, height above axis is positive in concave mirror, height below axis is negative in concave mirror. Okay, and convex mirror, here height above axis is positive and height above axis is negative. Here U indicate object's distance, F indicates focal length, and V indicates image distance. Okay, all of you understand this topic. I hope that all of you understand this topic. Now we have to discuss the next topic, mirrors formula. Here in mirror formula we use the three terms, that is F, U and V. F indicates focal length of the mirror, U indicates object's distance, and V indicates image distance. Okay. Here we have to write the formula of the mirror is the relation between object distance U, image distance V, and focal length F for spherical mirrors is given by the formula is called mirror formula. That is 1 by F is equal to 1 by V plus 1 by U. His derivation is here in brief. We have to take convex lens, convex mirror, concave mirror. Then here P is the pole, F is the U is the distance of object is indicates here U, and the distance of image indicates V. Okay, the height is H O means object's height, and image height is Hi. Okay, for the use of this indicate from similar triangles, triangle ABP and triangle A dash B dash P. These are similar in triangles. So we get HI by HO is equal to minus V by U. Use the sign conventions of spherical mirrors. Okay. From similar triangles, triangle PF A dash and triangle PC A dash, we get HI by HO is equal to minus F by U minus F. Use the sign convention of the spherical mirrors. These two equations are, we can take from equation 1 and equation 2, we take minus V by U is equal to minus f by u minus f. So simplify um, this equation. V into u minus f is equal to uf. That implies uv minus uvf is equal to uf. 1 by f is equal to, now 1 by f is equal to 1 by v plus 1 by u. Here the common factors of f. So uv minus uf is equal to, so uv is equal to uf minus vf. So f is common. So v plus u. Okay. So 1 by f is equal to uv by u plus v is equal to f. Then 1 by f is equal to u plus v by ue is equal to f. That divides to 1 by f is equal to 1 by v plus 1 by u. This is the formula of mirror. Here some important signs are given here. U is less than 0, object is in the front of the mirror. That is real object. Okay. Then if u greater than 0, object is behind the mirror. That is virtual object. V is less than 0, V means image distance. Image is in front of the mirror. That is real image. V greater than 0, image is behind the mirror. That is virtual image. F, suppose f is less than 0, that is concave. We use that concave mirror. F is greater than 0, we use here convex mirror. Okay. So diagrams from sign conventions here. Convex mirror. Already we have to shown the before session. Okay. Now uses of mirrors. Uses of mirrors. Already we have to discussing about the previous classes. Once again we have to check it. If any two of the three quantities u, v, f are known, the third quantity can be found using the mirror formula. That is the uses of mirrors formula. Okay. Spherical special cases. In special cases, object is infinity. Then v is equal to f. Image is at infinity. That is u is equal to f. Object at focus. That is v is equal to minus infinity. Okay. Type of mirrors. If we have to take concave mirror, then its focal length is negative. If we have to take convex mirror, the focal length is positive. Okay. These are the mirrors formula. About mirrors formula. I hope that all of you understand this session. Then we have to discussing. Then we have to discussing the next topic. Here we have to discussing about the magnification of these spherical mirrors. Now first we have to discussing about what is magnification. So its definition is magnification indicates m. Magnification of a mirror is a ratio of the height of the images hi to the height of the object ho. Okay. So that's formula is m is equal to hi by ho. Here hi is height of the image, ho is height of the object, and m is magnification of the mirror. Okay. For spherical mirrors, magnification is also given by m is equal to minus v by u. Here we have to calculate the magnification in other way. That is m is equal to minus v by u, where u is equal to object distance, v is equal to image distance. The distances are measured from the pole of the mirror. Okay. Here is also we have to use sign conventions here. So we already discussing about this sign conventions. Here interpretation of magnification. Interpretation of magnification here is given. Suppose magnification value is greater than m, nature of the image is enlarged, and size of the image is bigger than the object. If magnification is equal to 1, image is same size. So size of the image is, nature of the image is same size, and size of the image is same size of the object. Okay. If suppose magnification between 0 and f, 0 less than m less than 1, image is, the nature of the image is dimensioned. Yeah, so it means small size. Size of the image is smaller than the object. For suppose image magnification is 0, then nature of the image is highly dimensioned at infinity. Size of the image is point size. Suppose m is less than 0, nature of the image is inverted. That means real image. Size of the image is height is negative. Suppose m is greater than 0, image is erect. That means virtual image. Okay. Size of the image is height is positive. Okay. These are all interpretation of magnification. Easy to understand the topic of magnification. And we have to here nature of the image for different positions of the object. We are discussing the in table. It's shown in figure here. Beyond C. If point of the object is beyond C, then point of the image is between C and F, and its nature is real and inverted. Okay, its magnification is less than between 0 and 1 and negative. At C, if object is at C, then point position of image is at C. Nature of the image is real and inverted and same size. Magnification is -1. Okay. If position of the object is between C and F, that means between 2F and F, then the position of the image is beyond C. So here also nature of the image is real and inverted and enlarged. Magnification is m is less than -1. If object's place is at F, then nature of the position of the image is infinity. Nature of the image is real, inverted and highly dimensioned. And magnification is 0. M is equal to 0. So point of the object between F and P, that means F and O. Then point of the image is, position of the image is behind the mirror, and V is greater than 0 here. Nature of the image is virtual, erect and enlarged. Its magnification is m is greater than 1. So these are all ray diagrams also. Okay. Nature of the image for convex mirror. Nature of the image for convex mirror. Here for a convex mirror, the image is always formed between P and F. Okay. And that means behind the mirror. For any position of object in front of the mirror, the image is always virtual, erect and dimensioned. Magnification is also always positive and less than 1. That means between 0 and 1. Okay. All of you understand this magnification of the concave and convex mirrors. Here key points are there, some what we have to learn this topic. Use m is equal to v by u after finding v using the mirrors formula. The sign of m tells about the nature of the image. Is it erect or inverted? The magnitude m tells about the size, enlarged or dimensioned. Real images are inverted, so its magnification is negative. Virtual images are erect, so its magnification is positive. Okay, all of you understand this topic, magnification of spherical mirrors. I hope that all of you understand this topic, and giving this opportunity to teach to you. Thanks to all. Always be happy, and we have to learn to Josh. Okay, all of you keep it up. We will meet again in next session. Thank you to all. Please like, share, and subscribe my channel. Nobody don't forget it. It is useful to receive some more people to my video. Okay, thank you to all.